Particle Feeder.
And I'm Particle Paul, and we are Dark Matter Particles! Hey, so I'm Particle Paul, and because you guys requested this so much, we decided to do a Q&A video. So we asked you guys on Twitter to ask us some questions, and we got a bunch of responses. So now we're just going to answer a few. Let's get started.
Our first question comes from I Love Dark Matter, and they asked, what even are you?
Okay, a little bit rude, but honestly, I'm not too sure myself. I'm still trying to find myself. All I know is that I affect the universe and am made up of, well, something. All scientists believe something slightly different, but many theories have been proven incorrect. Some people believe that I am made up of a new type of particle that is never before seen and resists detection during the use of particle accelerators and cosmic ray discovery. They assume that I must be heavy, probably heavier than a neutron, and have weak interactions with normal matter due to my inability to produce light. People believe I would be made up of something similar to neutrinos. Neutrinos are particles that we are still trying to unfold and understand. They're one of the fundamental subatomic particles of the universe, but we don't know much about them. They're neutrally charged, and they are only affected by weak subatomic forces, and they're able to pass great distances without being affected by matter or greatly affected by any fundamental forces such as gravity. Sounds a lot like me, but not exactly. Hopefully after making videos like these, the knowledge you gain will allow you guys to be able to help me understand who I am and answer this question.
Woo!
Alright, so our next question comes from Caitlin, and she asks, what is your favorite color?
What do you think?
Next question.
So our next question comes from Science Lover 123, and they asked, how did Albert Einstein contribute to your discoveries?
Well, it's kind of a long story. Albert Einstein was, well, as per our knowledge, the first person to realize that empty space was not composed of nothing in the universe. Kind of rude. Me. Whether you believe that he was referring to myself or my friend Dark Energy, or the both of us, he predicted our existence. In addition, Albert Einstein showed that massive objects in the universe bend and distort light, which allows them to be used as lenses. I've explained this in a previous video when I talked about gravitational lensing. Either way, Einstein definitely knew something like me was out there. So thanks, Albert! Physics is Life 579 asks, how do you know that you aren't made up of baryonic particles or antimatter?
Well, baryonic particles are subatomic particles that make up visible matter, and specifically comprise dark clouds of normal matter, which is why you might assume that I am made up of these same particles. However, because we are so familiar with normal matter, we are quite excellent at detecting it. Therefore, if I too were made of baryonic particles, you would be able to detect my presence by the absorption of radiation passing through me. Since I can't be detected in this way, I am not made up of baryonic particles. I am also not made up of antimatter. Antimatter are molecules consisting of antineutrons, antiprotons, and positrons. Basically, they are the opposite of matter, which means it is a fair assumption to believe that I am made up of it. However, unique gamma rays are produced when antimatter destructs normal matter, which are not produced by me. In fact, there was a scientist's hypothesis in one of my previous videos that proposed that I might have something to do with the interaction of antimatter and matter, although I am not comprised of either one. Next, we have a question from Sarah Loves Science, and she asked, are you a black hole?
This is again a good assumption, but it's also false. The answer to this one is simple. Although many scientists believe that I surround black holes, it is impossible to assume that I'm made up of black holes simply because there is not enough evidence of lensing of the universe for black holes to make up the 25% ratio that I proudly say belongs to me. Our next question comes from Baryonic Bubbles. They ask, what is the difference between you and Dark Energy?
This question is important. Since me and my friend Dark Energy have the same first name, a lot of people assume that we're the same person. That's not true at all. Dark Energy has a larger part of the universe than I do. He makes up around 70% of it. First things first, Dark Energy is, well, energy, which is sometimes referred to as a force, while I am matter. Dark Energy deals with the expansion of the universe, while I am assumed to make up the universe's galaxies and clusters. In general, we both make up the same universe, but have different roles. Also, if you think you don't know much about me, try figuring out what Dark Energy is. Our next question comes from Sun-Kissed Physicist, and they asked, why are you so hard to find?
I'm so hard to find because I don't interact with electromagnetic radiation, which basically means that I don't emit any light, I don't absorb, and I don't scatter. I also only interact via the weak force. Well, rarely. The only reason you can usually find me is because of my gravity. I make it hard to find myself as my particles pass right by each other and we go right through everything else. Scientists try to detect me by my weak force interactions. but they happen so rarely. Sometimes my particles bump into the nucleus of an atom, but the results are quite inconclusive. Our next question comes from Super Science 42. How do you affect the universe?
Well, I'm the basic building blocks of the largest structures in the universe. Galaxies and clusters are examples of these large structures. It is thought that your solar system passes through a sea of my particles. They have a density of roughly 10 to the power of 5 per cubic meter. I'm also responsible for cosmic speeding. Neutrino 101 asked, what gravitational effects do you produce?
Well, the biggest gravitational effect that I have on the universe is gravitational lensing, which I explained in my previous video. A lot of you guys seem to be asking about it. The link is down below. Bacteria Bud, I like your name, asked, have you ever been detected?
Scientists have definitely detected things in the universe, but they just aren't sure if it's us. For example, many researchers have been analyzing data from X-ray satellites over the years. The European Space Agency's XMM Newton and NASA's Chandra X-ray Space Observatories reported the detection of faint X-rays in the universe as well as 3,500 electron volts of energy. The signal emitted from the center of the Milky Way, which affected Andromeda, its nearest neighbor galaxy, and several galaxy clusters. Who knows? Might have been me. Our next question comes from Doppler Gangster, and they asked, how did the Doppler effect contribute to your discovery?
Scientists often use the Doppler effect to detect my existence. The Doppler effect can be explained by what is seen by an observer when a source of waves is moving. The effect shows an upward shift in frequency when the source is approaching the observer, and a downward shift when the source is receding, although the frequency of the source remains the same. This concept is also used by scientists to, as they like to call it, catch my particles. Humans are strange. Anyway, since my particles move differently than those of a gas, scientists can predict my presence. To be honest, along with being mysterious, I'm pretty adventurous and I like to change things up often. As a result, I like to move in random directions. By using the Doppler effect, scientists measure the Doppler shifts in different directions of a source. For example, X-rays, and they are able to conclude whether the particles are dark matter or not. Since I move in random directions, the Doppler shift would be 0 in all directions. So I guess you could use the Doppler effect to figure out where I am, even though it hasn't really worked that well yet. Thanks for watching!
I'm Particle Peter.
And I'm Particle Paul, and we'll catch you next time on Dark Matter Matters!
Y'all ready for this? No. Dun, 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 dun. Since I move in random directions, the Doppler shift would be 0 in all directions.
As well as 3,500 electron volts. 100.
Okay, I'm good.
The Doppler shifts in different directions of a source.
Particle.
Physics is life.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy. Psh, psh.
Okay.
Oh.
Oh.